Hey, hello beautiful people of SalesConf. My name is Luciano and I'm here for the second year and I'm absolutely thrilled to be here again, and I hope you're going to enjoy this talk and hopefully we're going to learn something new together. But before we get started, I want to share the slides with you. They are already available online, so you can either scan this QR code or go to the link that you see there. And this is because I'm going to be showing you a bunch of code examples and links. And this way you can be sure to have all the material ready at the end of the presentation in case you want to reach out to ask questions or you want to review something. Okay, let me start by introducing myself. As I said, my name is Luciano. I am a MVP, Microsoft Most Valuable Professional for Developer Technologies. I'm also an AWS Associate Solution Architect Professional, and I work as a Senior Architect at Fortiorem in Dublin, Ireland. One of my biggest achievements and one of the things that I'm mostly proud about in my career is being the co-author of this book called Node.js Design Patterns together with Mario Casciaro. And it's a book that is going to be very relevant for this talk, so I'm really curious to hear your opinion, if you read it already, or if you're going to read it in the future. Feel free to reach out to me and let me know what you think, what can be improved, if you learned something new, or if you have any idea for how we could extend the book and make it better in the next edition. You can reach out to me in many different channels. I'm very active on Twitter, but feel free to also connect on all sorts of social channels that you see there. Just a few words about Fortiorem. We are a professional service company and we are a group of generalists. We really love technology and we like to build projects with our customers. We are particularly specialized on the field of cloud computing, in particular on AWS. So most of our work revolves around helping customers to move to AWS or improve their AWS deployments. If this is something that is interesting to you and maybe you want to work with us, definitely feel free to reach out because we are always looking for talent. Okay, let's start the talk. I want to start it with a fact. Async JavaScript is tricky. And if you don't believe me, the main reason why I want to say that is because there are so many concepts and so many ways to do very similar things, and sometimes that can be overwhelming. And yes, I'm talking about callbacks, promises, async await, streams, event emitters, async generators, util.promisify, Promise.all, Promise.all.Settled, and so on. There are many concepts, and it's okay to be confused. And hopefully with this talk, we're going to try to have a better understanding of the whole async story in JavaScript. Okay, so today what I want to cover is, first of all, why async exists and why it is important, what are the trade-offs. Then we're going to discuss callbacks, then we're going to cover promises, async await, some interesting async patterns. We're going to discuss how to deal with mixed style. So for instance, when you want to use async await, but you have a callback-based function, how do you go from one to the other? Or vice versa as well. If you are forced to use callbacks, but you want to use async await, what are the compromises there that you can do to be able to use the style that you really prefer? And finally, I'm going to try to close this talk with a performance trick that can be useful in certain circumstances. And that performance trick really illustrates that if you understand the differences between async promise, callbacks, async await, and all the journey, you can really leverage that to your advantage and come up also with interesting performance tricks. So let's start by trying to describe what async even means. So JavaScript is kind of a peculiar language on its own because every time that you have to deal with input and out operations, those operations are said to be non-blocking. And a classic example is, for instance, when you want to read the content of a file, when you're doing an HTTP request, or when you're loading data from a database, all these operations are input and output operation, and those behave in a very specific way in JavaScript. And I want to illustrate what's the difference of how JavaScript behaves compared to other languages that are considered blocking. And this is a very trivial piece of pseudocode. Basically, what we are doing is like three different operations. We assign a variable, which is generally a synchronous operation. Then we read data from a file, so there is an I/O operation there. And finally, we print something to the standard output. So let's compare how the code flows, how the code is actually executed in the two different cases, blocking style language and JavaScript. So the first line that gets executed is assign a variable, and this is a synchronous operation in JavaScript. So basically what happens is that, in both cases, this line is just executed and we move on to the next line. In the next line is where something more interesting happens. We are doing I/O, we read data from a file. So what happens is that in the blocking style language, the operation starts, and also in JavaScript, the operation starts. But the difference is that in the blocking style language, the operation blocks the execution of the code. So while the operation is in progress, nothing else is going to happen. In JavaScript, instead, the operation continues in the background. I know this is not the most accurate way of saying that, but let's keep it simple for now. You basically are still running that I/O operation somehow, but your JavaScript code actually is already moving to the next line. So it's going to print something to the standard out, and then eventually the I/O operation completes. And what happens in the JavaScript version is that we are already done because there is no more code to execute, while in the blocking style, it will unblock, move to the next line, print to standard output, and only at that point it will be done. So you probably get the idea that non-blocking I/O is convenient because basically we can do more work while we are waiting for I/O, and we can do that without having to think about threads and synchronization. It's like a very simplified model from kind of a developer perspective. But the part that starts to get tricky is basically when we start to wonder, okay, but in that trivial example, we didn't really want to know about the I/O operation. We didn't really use any output from that I/O operation. But in real life, we most likely want to do something when that operation completes. So how do we start to coordinate different things happening in our code asynchronously? And how do we create a flow of data? And how do we organize the code around that flow? And the first thing that was available in JavaScript, and is the thing that existed since probably forever, since JavaScript existed, is callbacks. And let me try to summarize how callbacks work. So a callback is basically a function. You have a function that needs to do something asynchronous, and this function is basically receives different arguments that are needed for that particular function to perform its own business logic. And then the last argument is this interesting CB argument that indicates that we are expecting a callback. So what is really a callback? A callback is nothing else than a function that we pass inside this other function. And this function is basically saying, whenever you are done with your asynchronous work, please invoke this callback function I'm giving you. This is why it's called callback, because it's literally saying, once you're done, call me back through this function. And it's interesting because generally callbacks follow this pattern where there are two arguments. The first argument is an error, and the other argument is the actual data that is the result of the asynchronous operation. Now, that means that the asynchronous function, do something async here, will call our callback either in case of error or when it completes successfully, and we will be able to tell what is the difference based on the argument that we receive. So basically, we always need to check, was there an error? If there was an error, we need to handle the error. Otherwise, we can do something useful with the data. Now let's look at an example to understand better how to use callbacks. And the example is, let's imagine we're working on a booking website, maybe we're managing hotels or something like that, and we want to fetch the latest booking for a given user. And if that booking exists, so if that user has booked something, then we print the booking. So how can we write this with a callback-based style? We can create a function that is called getLatestBooking. Actually, here we are assuming that this function exists somewhere in our sets of APIs and libraries. So here we are more illustrating how to use that function with a callback-based style. So getLatestBooking most likely is going to connect to a database, which is an asynchronous operation. So we are providing a callback to be notified when that operation finishes. So this is the callback we are passing when we use getLatestBooking. And we need to handle potential error first. And then if there is no error, and if there is a booking, we can do something with it. Otherwise, we can just say there was no booking. So this is pretty simple. So now let's think of a slightly more advanced use case. So we get the latest booking for a user, but now if that booking exists, we want to cancel it. And again, if we are cancel it and the user already paid for it, we want to refund the user. So there is a little bit more of control flow here, and you can see how all the steps that we are describing here are basically different sequential asynchronous steps. So we'll need to figure out a way to manage all the asynchronous step and move from one to the other once the previous one completes. So let's see how we can do that with callbacks. Again, we are assuming that we have a bunch of helper functions. For instance, we have a function to get the latest booking, a function to cancel the booking, and a function to refund the users. So this is more implementing the flow by leveraging those pre-existing functions. And all these functions are callback based. So cancel booking is the one that we are going to be calling if we were able to fetch the latest booking. And we pass the booking ID. And then we have to check if that booking that we just canceled, in case of success, was paid, then we want to refund the user. So there is another function we are going to call, and this other function is asynchronous. So again, we are passing a callback, and if everything was okay, we just say the user was successfully refunded. Now, there are a few interesting things that don't worry too much about the overall code. I'm going to highlight a few interesting things that are worth looking at here. The first one is that we have a lot of repeated code, specifically around error handling, because for every callbacks, the first thing we definitely need to do is make sure that there are no errors. And if there are, we just need to notify the user, log the error, and stop the processing there. Then another problem is that here we have a nested callback. So inside a callback, we are calling another asynchronous function. We need to pass another callback. And there is even another level of nesting. So because we are doing 3 sequential asynchronous steps, for every step, we kind of keep nesting callbacks inside callbacks. And if you look at this code, there is actually a common joke, because this used to be very frequent in the old days of JavaScript. And this is that the code keeps moving to the right side. So you keep nesting more and more, the more you have asynchronous steps that you need to run in sequence. And this was called the pyramid of doom, or callback L. And very commonly, it was associated to this kind of picture of the Hadoken pushing your code to the right rather than flowing nicely from the top to the bottom. Now, this used to be a problem, but sometimes just refactoring the code in a very creative way can help to keep it clean. And I just want to show you an example. One way that we could make this code better is that we could have a utility function called cancel and refund booking. And this utility function is basically a callback-based function that we are creating in addition to the ones that we already have. So what this function needs to do is basically receives a callback. And then what we do is that it's going to call cancel booking. If that operation fails, we call the callback with an error. Also, it might fail when we try to refund the user. So in that case as well, we call the callback with an error. If we succeed, instead, we just call the callback and return some sort of result. For instance, here we are returning the refunded amount. It can be either 0 if the user didn't pay for the booking, or it can be a certain amount if the user already paid for the booking and we refunded them. Now, the interesting thing as well is that we inverted here our conditional to be able to return earlier. And before we were just taking if booking paid, then refund. Here we are just saying if the booking was not paid, just return, because we don't need to refund the user. So here this helped us to reduce the number of branches in our code. So sometimes being clever with the if conditions can help us to keep our code cleaner and less nested when using callbacks. Now, on the other side, how do we use the function that we just created? We basically call in line 8 cancel a refund booking, and we pass a specific callback. And this callback is just going to check were we able to cancel a refund. If yes, just print it. If no, just deal with the error. And here with this approach, you can see that we removed one level of nesting, and the code is a little bit cleaner because it's split into different parts, like kind of a generic cancel a refund booking function, and then our specific business logic that we wanted to implement. But you might wonder, okay, is this the best we can do? I don't want to write code, and every time I write asynchronous code, I have to think, okay, this is getting messy. How do we refactor it? Let's try a different approach. It might take a long time to actually figure out a nice way to write code using callbacks. So maybe we can do something that is easier to manage, and we don't have to worry as much about how do we structure our code. And at some point in the history of JavaScript, this concept of promise was introduced to try to solve some of the problems that we just described with callbacks. The problem with callbacks is that we are not really in charge. So we really need to trust that the asynchronous function we are calling will eventually call the callback we are passing with either a success object or an error. And this is why things get more complicated, because we just keep nesting, okay, call me back, call me back, call me back. And we are not really in control of seeing what's going on with the asynchronous operation from the outside. And promises try to invert that particular pattern. And the idea is that when you call an asynchronous function, rather than passing a callback, you receive back a return object. And that object is what is called a promise object. And the goal of a promise object is to represent the progress of an asynchronous operation. So in a way, it's a kind of a tiny state machine. And this state machine has two different states, can have either one or the other state. And one state is pending, which literally means, okay, I'm still doing progress on this asynchronous operation. I'm not completed yet. And the other case, the other state, is when the promise is completed. And when it's completed, we can actually have two different outcomes. One is fulfilled, which means the promise completed with an actual value, so completed successfully. And the other one is rejected, which means there was an error. So I am rejecting this promise with a specific error. And this tiny state machine never goes back to pending, so it's only executed once. It will be pending for a while, and eventually it's going to be settled either with success or with an error. But how do we actually interact with the promise object? We can use this syntax.then, and this basically says, okay, when you are completed and you have some data available, now I want to do something with it. So this is like setting up a listener in a way, and we are saying on this promise object, when you are complete, allow me to run this function. And then the other case is when there is an error, we can use promiseObject.catch and specify a function that allows us to deal with errors. And you might wonder, okay, is this really different from callbacks? Because at this point it looks very similar. We still need to pass a function that will be invoked when something happens. And this is actually true. It's not too different from callbacks, except that promise objects support chaining. And chaining allows us to keep chaining different asynchronous operations. And basically the way it works is that we call a function that returns a promise, we receive a promise object, then we can call then in the promise object. And every then step inside the function we pass, we can keep returning more promises. And we are basically this way creating a chain of promises that gets executed in order. And for every step, the function we pass to the then method receives the output of the previous promise. So we can also keep chaining and passing input and output from one promise to the next. And finally, if we use a catch statement, a catch function, that catch function will catch any error at any stage of this pipeline that we created by chaining promises. So this is also convenient because it removes duplication in error handling. And you can see that by doing this, we don't nest the code, we don't keep nesting the code that goes to the right side as we saw with callbacks, but it keeps flowing down nicely and more sequentially. There is also another thing that is quite interesting that is called finally. That finally will run in either cases, either the promise completes successfully or there is an error. In both cases, it will run the then or the catch block, but we always get to run the finally at the end. So this can be useful when we want to clean up maybe some resource that was allocated while the promise was running, and we want to clean up regardless if there was a failure or a success. But now you might be wondering, how do we create a promise? Let's say that we want to create our own function that is asynchronous and returns a promise. How do we do that? To create a promise, we just need to use the constructor, new promise. And this constructor receives only one argument, and this argument is called executor function. This is basically a function that will be executed immediately once the promise is initialized. And this function has a very specific signature. It receives two arguments, a resolve and a reject function. And basically the idea is that we can do something asynchronous inside this executor function. And eventually we need to call either reject if that asynchronous operation failed, or resolve if that asynchronous operation completed successfully and we want to transition to the resolved state with a given value. There are also some shortcuts because sometimes you might want to just create a promise that is already resolved or rejected. You can use these two helpers, promise.resolve and promise.reject. Okay, now let's look at an example. Let's say that we have we want to query a database, or we want to create a generic query database piece of functionality that returns a promise, and we can pass to it a client and a query, like a SQL query, and we want to abstract all the execution of the query and just get back the result or an error. So what do we need to do? Is basically in the body of this function, we return a new promise. We define our executor function for that promise. At this point, we can do a specific asynchronous operation. In our case, we use the client to call the method execute query. We pass the query. And then because this client is most likely callback-based, we need to pass a callback. And in this callback, we might have either an error or a result. If there is an error, we deal with the error and we propagate it by calling the reject, which will make the promise settle with a rejection. And the rejection is going to contain the specific error of the query execution from the client. Or if everything was successful, it means that we have some data and we can transition the promise to the fulfilled state resolved with some data. Now here you can see that our promises are still quite related to callbacks. You still need to understand callbacks and be able to use callbacks very well if you want to be able to create promises effectively. Okay, now let's look at how do we use this function that returns a promise. So we can query the database. For instance, we want to do a select asterisk from bookings. And basically what we do, we pass a client, we pass the actual SQL query. And at that point, we receive a promise object. So we could call .then to do something with the bookings data, or we can do .catch to, for instance, log the error if there was any error. And we can also have a finally block, for instance, if we want to disconnect the client after we completed the query. Now let's rewrite our example, the one we analyzed before, using promises. So we want to fetch the latest booking for a given user. If the booking exists, we want to cancel it. If the booking was already paid for it, we want to refund the user. Let's see how that looks like. So basically what we do here is that the first thing that we might notice is that there is no pyramid of doom, but it's tricky to handle optional async steps correctly because you can see already that there are a lot of if statements. But this is going to become a little bit cleaner when we go through the different blocks. So we get the latest booking that returns a promise for a given user. Then we have this block where we say, okay, then if there was a booking, what we want to do is call the cancel booking function, and that is going to return another promise. So in the next block, this block will be executed, and what we can do is basically say, okay, if there was a booking that was actually canceled from the previous step, then we need to see if we need to refund the user. So if that particular booking was paid for it, we need to return the promise that comes back from calling refund user. And again, we end up in another then, and if there was a refund, we just want to say user refunded. And finally, we also manage errors. So you can basically see how this code is kind of a little bit nicer than before because it's a little bit more sequential. There is less nesting. and the steps are clear. But the problem is that because we have optional steps, we might want to refund the user or not, depending if the booking was paid or not. It becomes tricky. We have a lot of if statements there to decide, okay, do I just want to return a promise or just do nothing? In the next step, you don't really know, okay, what happened before. So you just need to, again, assess, okay, is there something that I need to do here? And there is, again, another if statement. So a better solution to all of these problems is async await, which is the most recent addition to the asynchronous capabilities of JavaScript. So let's try to explain what that does and how it can help us to write cleaner JavaScript asynchronous code. So the idea is that sometimes we just want to say, okay, I have this promise that represents an asynchronous operation that is happening. I just want to wait for this promise to finish before I move to the next line. And await does exactly that. So we can just have a promise object, we can put await in front of it, and the result is going to be that JavaScript is not going to execute the next line until the promise settles. And the other thing is that if the promise settles with an object, so if the promise fulfills, the data that is contained in the promise is going to be returned from this kind of await promise object statement. So we can immediately assign it. So we're kind of unwrapping the value out of the promise. Or if there is an error, that await statement will actually raise an exception. So we can capture the error with a try catch. So basically what I'm saying is that, well, first of all, we don't even need to assign the promise object. We can await directly from the function call, which makes the code a little bit more concise. And this is how generally you will see people using await. Then, as I said, if we want to handle errors, we can just wrap the whole thing in a try catch and manage the error in the catch block. And this is interesting because at this point, we can try catch both asynchronous and synchronous errors in a kind of a unified way. So it's easier to make sure that we are capturing and dealing with all sorts of possible errors. But there is another concept that is related with async await. So far, we only discussed await, but there is also this concept of async functions. So async is a special keyword that you can put in front of a function and makes your function a little bit special. And let's see how special it becomes. Well, basically, in an async function, we are kind of implicitly always returning a promise. So an async function will immediately return a promise, and that promise is pending while the function is still executing, and it will settle whether we throw an exception inside that function or whether we return some value. And for instance, here we are saying, okay, this function just immediately returns some value. So this code is pretty much semantically equivalent to a regular function without async. And this function immediately returns promise.resolve some value. Similarly, if we throw an error, this code is semantically equivalent to this other function that is not async, where we immediately return a promise that rejects with a particular error. Okay, but in reality, why do you want to use async functions? Because inside async functions, you can use await. So you can describe all the different steps that needs to happen with a particular control flow. For instance, here we are just sequentially calling functions, and we can take the result of the first function and pass it to the second one, and so on. So here we can use await to say, there is a promise there coming back from that function call. Don't go to the next line until that promise settles. Take the result, res1, and then move on to the next line. And in the next line, we keep doing asynchronous operation. And you can see how this code is much more readable, concise, and it's clear what is the order of the things that are going to happen. Now, the interesting part is that when we have complicated control flow, for instance, when we have if statements or loops, we can use await very effectively to describe when to stop and wait for that promise to complete, or when we want the code to keep going ahead. So here the code becomes, again, very readable, and we don't have to have many if statements in a promise chain like we saw before. Okay, so again, let's do the exercise of trying to rewrite our use case, but this time using async await. Just as a reminder, we get the latest booking for a user. If that booking exists, we cancel it. If the booking was paid, we need to refund the user. So how does it look using async await? We do everything in a function called cancel latest booking. This function is marked as async. So when we call this function from the outside, we will be returning a promise. Now, what is going to happen when the function runs? The first thing we want to do is to get the latest booking, and we don't want to do anything else until the booking is available. So we use await. Then if the booking does not exist, we can log that there was no booking for this user, and we can return. If the booking exists, we just say, okay, we actually found a booking, and this is the booking, and now we want to cancel it. And we don't want to do anything else until the cancel successfully completes. If the cancel successfully completed, then we refund the user only if that user paid for it. And at that point, we want to await for that operation to complete, and we are going to say, okay, the user was successfully refunded. Now, of course, this is illustrative. You might argue that you're not going to cancel the booking before you refunded the user. So don't worry too much about the business logic here. It might not be the best implementation for this kind of use case, but I just wanted to illustrate a sequential of asynchronous steps and some of them being optional. And here you can clearly see that async await is giving us the best style, the most readable style and easier to maintain compared to promises and callbacks. So if we want to do a mini summary right now, we just say that async await is probably the best option in most cases to keep the code simple and readable. Then to use async await, you need to understand promises, because we have seen that await can be used in front of a promise object. So we really need to understand what a promise object is and how it behaves to understand what is going to happen with that await statement in front of the promise. To use promises, we saw that you need to understand callbacks, because most of the time, if you need to create your own promises, you need to do it through callbacks. So you need to be confident with that. So there is a very clear journey. We start from callbacks, we end up to promises, we end up to async await. And my suggestion is don't skip any of these steps when you're learning JavaScript if you really want to be comfortable using async await and avoid mistakes in your code. Okay, now I want to quickly show some async patterns. The first one is sequential execution. So for instance, we have an array, and based on that array, we want to run a number of asynchronous things, one after the other. So we don't start the second one before the first one has finished, and we keep going until there are items in the array. For instance, if we have different users, we want to cancel the latest booking for each and every one of these users, but we want to do that in series, so in a particular order and not in parallel. How do we do that? We basically do a regular for, and so for every user ID in this list of users, just call cancel latest booking, that will return a promise, but we want to await for that promise. So this loop is not going to continue to the next iteration until the current item is completed. Now, there is another way that you could do this, but it's a little bit dangerous. So this is not going to behave as you might expect. If we use users.forEach, for instance, rather than just doing a regular for of, what is going to happen is that for each doesn't really care about the kind of function you are passing. If it's an async function or if that function returns a promise, it's not going to wait for that promise to complete. It's just going to keep calling the function for every item, regardless of what's the status of the promise represented by our async function. So what is going to happen if you try to do this is that we are not executing the canceling of bookings in series, but we actually execute that concurrently. So if you have hundreds or thousands of users, you will actually start hundreds or thousands of asynchronous operations in a concurrent way. So just be careful, because this is one of the common gotchas when doing this kind of patterns. Instead, if you actually want to execute things concurrently, what you can do is to use this concept of Promise.all. And Promise.all is an helper function that basically what it does, you can pass it a list of promises. And here we build a list of promises using users.map. And for every user ID, we get the promise by calling cancel latest booking. So Promise.all will get this list, and it's going to keep checking all the promises. And then once all the promises finish correctly, it will resolve. So it basically returns another promise, like kind of a higher level promise. And this promise will resolve only when all the other nested promises are completed. But if one of the nested promises rejects, the whole high level promise is going to reject as well. So this is kind of a pattern where we are saying, okay, do everything concurrently, but if something fails, just fail this particular promise straight away. And this is also tricky because it doesn't mean it's going to stop all the other operations, because there are still promises running in the background. So just be careful, because this might be a little bit misleading in case of errors. A better approach is to use another method called Promise.allSettled. And what this one does is basically is not going to stop when it's not going to reject the promise when some of the inner promises rejects, but it's going to return you an array. And in this array, you have a description of every single execution of the nested promises. And this execution is described with status and value. In case of success, you will have status fulfilled and value true. Or in case of error, you will have status rejected and reason with the particular error of the rejection. So with this approach, you have a much safer way to actually figure out after the whole asynchronous concurrent operation was completed, what to do. Was there something that failed that maybe needs to be retried or reported, or everything was okay? So this is a little bit of a more controlled and obvious way to monitor for multiple potential failures that can happen independently in the different sub-promises. Now, one of the latest topics that I have is mixing async styles. So for instance, if you want to use async await, but you have a callback-based API, what can we do there? And one interesting thing is that in Node.js, you have APIs, and those APIs are callback-based, but sometimes you have promise-based equivalent for those APIs. So for instance, if you want to use set timeout, set immediate, or set interval, those are all callback based by default, but you can import this library called timers from timers/promises, and there you will find alternative version to set timeout, set immediate, and set interval, but rather than using callbacks, they will just return a promise. So in this case, you can easily use async await and not having to deal with callbacks. Similarly, for file system operation, there is another module called fs/promises, which has very similar interfaces, but they are promise-based rather than being callback-based. Similarly, for some stream utilities, you have stream promises and DNS and so on. There is another interesting utility in Node.js called util.promisify that allows you to convert a callback-based function into a promise-based function. So for all these cases where there wasn't already a built-in implementation that support promise, you can actually take a callback-based function and promisify it yourself. And one example that I have here is, for instance, gzip. So if you want to compress a binary blob or a piece of text, for instance, that is still callback based. There is no built-in promisified version. So if you really want to use async await there, you can do it by promisifying the gzip function yourself. So let's see how to do that. So here we import gzip, and gzip is basically a function that looks like that. You can see in the comment that you pass a buffer and you need to pass a callback to be notified when the gzip is completed and what was the gzipped data resulting from the process. Then we import this utility, promisify, from the util module. And then how do we promisify this function? We literally call the promisify utility and we pass the callback-based function. And what we get in return is a new function that it will be a promise-based version of the original function. So at this point, we can simply use this new function, this gzip promise, and we can await the result because we know we're going to receive a promise. We can await that promise, and then we access the compressed version of our buffer. But what if you are running in an environment where you don't have the utility from Node.js? For instance, what if you want to promisify something in the browser? How can we promisify something ourselves? Now, just for the sake of keeping things simple, I'm going to re-promisify the gzip example from Node.js, but I just want to illustrate how you can promisify any function, even in cases where you don't have the util.promisify helper function. So here what we are doing is we are creating ourselves a gzip promise. And basically, this one doesn't have to be async because we are going to be returning a promise ourselves. And the reason why we return a promise ourselves is because this thing is going to be callback based. So we can just return the new promise and manage the callback in the executor function of the promise. So what we do, we actually call the original API, so gzip with a buffer, options, and then the callback. And basically what we do in the callback is literally saying, okay, if there was an error, I need to reject. So the promise that is going to be returned by our promisified version of the function will reject with that particular error. Or if everything was okay, we can just resolve with the resulting gzip data. And then we keep using it in the same way as we did before. So our util.promisify from Node.js is doing something similar to what we just illustrated here. It's just a little bit more clever in handling all the arguments and making sure that the callback is always the last argument. Here, because we already know in advance the signature of the gzip function, we kind of built a more specific version of that promisified function. So this is just to show you that it's not that complicated to promisify a function if you are in an environment that doesn't have that util.promisify. Okay, but what if we want to do the opposite? So we have, this is a little bit of a weird edge case, but sometimes it happens that you have a promise-based function and you want to convert it into a callback-based one. Maybe you wrote some code using async await, so that's a promise-based function, but then you want to pass that function to something that instead is looking for a callback-based function. So in that case, you probably don't want to rewrite your entire function, but you want to do some wrapping that allows you to expose a callback-based interface for your particular promise-based function. And now, because this is a little bit of an edge case, I want to give you a realistic example that actually I needed to deal with quite recently. And it was interesting to see how to do the opposite approach. So rather than promisifying, we are going to callbackify a promise-based function. And now the use case that I had was with Nunjuck's async filters. So Nunjuck is a template language for JavaScript, inspired by Python Jinja, if you are more familiar with that. And it basically supports this kind of syntax. So in a template, so you are producing, for instance, some HTML, you might have some variable, which is going to be the input data here. And then you have this pipe, and on the other end of the pipe, you have a transformation function that is also called a filter. And you also can create asynchronous filter. And the example I was working with is I had this piece of content that I wanted to display on a page. So in my template, I had a YouTube ID that represented the video content, and I wanted to be able to fetch from YouTube the title related to the video through the ID and just print the title instead. So this is basically me doing some processing, saying I only have the ID of this YouTube video, but in the template, I finally want to render the title. So I need to go and do an API call to YouTube, use the ID, get the video information, get the title, and then at the end, in our final result of the generated page, we'll be able to see the title instead of the ID of the video. So how do you implement all of that with Nunjucks? So Nunjucks actually has a callback-based interface to that. So when you have to add your own custom filter, for instance, here we want to add a filter called video title, it forces you to provide the logic for that filter through a callback-based API. But because we want to use async await, how do we deal with that? And there is a utility in Node.js called util.callbackify, which literally does what we want to do. So we simply import that utility. Then here I'm using a library called innerTube to deal with the YouTube APIs. And this is basically my promise-based function. So this is an async function that initializes a new innerTube client. It uses the client to get the details of a video through the ID. And finally, we just return the title of that particular video. So this is the function that we want to callbackify. How do we do that? Simply, we call callbackify and pass this function. We get back a new function that is a callback-based version of that particular function. And at that point, you can just use this function as a callback. So you just pass an ID of a video, and it should give you back a video title in the callback. Now again, what if you have to do all of this yourself? Because maybe you are doing something like that in the browser and you don't have this callbackify utility. It's actually pretty simple to do it yourself. So what we are doing is we are doing video title filter callback based. And this time we also need to receive a callback. And what we do, we call the asynchronous version of the same function. This will return a promise. Then what we do, in case of success in the then block, we just pass the result to the callback. Or in case of error, we are going to pass the error to the callback. And this is literally what it takes to callbackify a promise-based function. Now I have one last piece of content, and I hope you are still with me. And you might be wondering, okay, how is this stuff useful? Is it really worth for me to kind of spin my head around all these concepts and try to master callbacks, promises, and async await? I would argue that yes, it's useful because in JavaScript, you're going to be writing a lot of code that needs to be asynchronous. Every time you deal with I/O, you are dealing with asynchronous code. So being comfortable doing all of that and implementing different control flow logics is very, very important. But if you're still not convinced, let me show you an interesting performance trick that you can do with web servers. And you can only do that if you really understand promises and async await and how these things actually work. So this is the use case. In a common web server with a database in the backend, if you have a user doing a request, for instance, a user is calling an API to get a list of hotels in Rome, what is going to happen is that most likely the web server is going to issue a query to the database, get the data for the user, and then send back a response. Now, if you have a very successful website and you have multiple users at the same time trying to find hotels in Rome, what is going to happen in a kind of classic implementation is something like this. So the first user arrives, starts the query, and the web server is going to go to the database to try to get the data. While all of that is happening, a second user arrives as well, does the same query. So the web server very naively starts another query to the database again. And also a third user is going to do the same. And again, a third query to the database starts. Then, as soon as we have a response for the first user from the database, the web server is going to package a response for the user. And this is going to happen also for the third user and the second user, depending on which query finished first in the database. So this is a very naive approach, and you might realize already that we are basically bombarding the database with queries that we don't really have to do 3 times, because if we just can capture that result once, then we could reuse the same result for all the other users while that request is in flight. So a smarter implementation here is what we can call request batching pattern. It's basically our web server has a little book where it keeps track of the requests that are in flight. So when the first user arrives and asks for hotels in Rome, what it's going to do is starts a request to the database or sends a query to the database, but this time it's going to keep track and say, okay, I know that right now I'm waiting for a response from the database for this particular request. So if a second user comes in at this point, our web server actually knows that, well, I don't really need to issue the same query again because this query is already happening in the background. And again, for a third user, it's going to do the same. And you can imagine a fourth or a fifth and hundreds or thousands of users trying to do the same thing at the same time. Eventually, when the database query comes back, the web server says, okay, now I have an answer for all the users that are actually waiting for this particular query to finish. So I can mark my request in flight as done, and I can return a response to all the users that are waiting. So you can see how this approach allows us to save basically the database from running a lot of queries, but also probably is going to have a performance effect because we are not doing a lot more work when it's not actually needed. Okay, how can we implement this? So the web server is actually very simple. We import create server from the HTTP module. Then this is really simple. In real life, you're probably going to be using a web framework like Fastify and manage your routes differently. Here, I'm just using a regex to make sure that we are able to parse the URL and the path and extract the ID of the city from the path. Then we create the server and we define how the server needs to behave with this function being passed to the create server utility. So the first thing that we do, we parse the URL, we get the path, and we run the regex through the path. So if that regex didn't match, it means that we don't really have, that the user is requesting for a URL that we don't support, so we just return a 404. But if it matches, we can extract a city from that path, and then we can call this utility function get hotels for city. And at that point, we should get back a promise. We await that promise, and when that is finished, we have a list of hotels, and we can just return to the user this list of hotels. Okay, all of that is interesting, but we haven't seen any batching yet. And the reason is because the batching is actually done in our utility function called get hotels for city. So let's see how that works. We said that we needed to keep track of the pending requests, so we can do that with a map. In our case, a request is identified by a city ID. So if we see a new request coming in with the same city ID, we can check against this map to see, are we already processing that, or do we need to start that processing for the first time? So we define this helper function, we receive a city ID, and this is what we're doing. So the first thing we check is if that city is already in progress, we are going to have a promise saved in our pending request map, so we can just return that promise. But if that is not the case, that means that is the first time we are going to do that query. So we initialize that query, and we get back a promise. Notice that here we are not using a wait because we don't want to block the code here. We just want to capture the promise and save that promise into an object called async operation. At this point, we need to save that asynchronous operation in our map. So if somebody else is going to do the same request while we are still progressing with this promise, they will receive the same promise. We also want to clean up this result. We don't want to keep it in cache forever. You might use different strategies here, but the strategy that I'm using is basically when that promise is actually settled. So when we return to all the users that are waiting at the same time, we are going to clean the cache. And next time somebody asks for the same city again, we're going to start with a new query. You might even have a timeout here if you want to keep things around for, I don't know, let's say 5 minutes, 10 minutes, 1 hour, whatever makes sense for your use case. And finally, we return that particular promise. So we could return the promise that is already in flight, or if we just created the promise right now in this request, we will be returning it at the end. Now, if you want to see how much that can affect your performance, I have done some artificial benchmarks. So word of caution, they might not be representative for your particular use case, but in this particular benchmark that you can check online yourself, there was an improvement of 90% average request per second. So this is a massive improvement if you have a lot of concurrent users. I think in this case, I was simulating with 20 concurrent users for 20 seconds, and the improvement was pretty significant. Okay, so just to close this talk, JavaScript can be a very powerful and convenient language when we have to deal with a lot of I/O operations, which is very common when you write web servers. The async story has evolved a lot in the last 10 to 15 years. New patterns and language constructs like promises and async await emerged. So today we can take advantage of them, but we don't need to forget about all the history because it's important to understand these new constructs. So async await is probably what we want to use today because it's kind of the easiest and the cleanest. But to use it, we need to learn promises and callbacks. So again, take your time and invest in learning the fundamentals. And this is all I have for today. I hope you enjoyed the talk. Feel free to connect with me if you have questions. And if you want to check out the book, again, there are different chapters that explores a lot more in depth the topics that we have discussed today. There is an entire chapter dedicated to callbacks, one to promises, one to async await, and then you have different chapters for all sorts of different patterns. So I hope you enjoyed this, and thank you very much. Bye.